So say I give you a function that looks like this. F of x is equal to 2x squared plus 3. What I want you to do is to evaluate f of 0, f of negative 3, and f of 2. So let's start with a. So if we have f of x is equal to 2x squared plus 3, then what happens with f of 0 is that every time you see an x within the function, you replace it with 0. This notation doesn't mean that you multiply the function by 0, but that you replace the independent variable x with 0. So in this case, since there's an x squared here, this becomes 2 times 0 squared plus 3, and 0 squared is 0 times 0, which is 0. So 2 times 0 plus 3, and then 2 times 0 is 0. So f of 0 is equal to 3. Now, for part B, we're evaluating f of negative 3. So again, looking at the function f of x is equal to 2x squared minus 3, plus 3. Now, we do the same thing, except instead of replacing the x with 0, we replace it with negative 3. So f of negative 3 is 2 times negative 3 squared. Now remember, the squared is only affecting the 2. If the square were affecting, the square is only affecting the x, not the 2. If the square were affecting the 2, then it would be 2x squared, right? The whole thing would be under parentheses, but then since there's no parentheses, then it's just x squared. So this is 2 times negative 3 squared plus 3. Negative 3 squared is 9, so we got 2 times 9 plus 3, which is 18, plus 3, which is 21. And then finally, part C, we want to evaluate f of 2, right? So f of x is 2x squared plus 3. Let me just make sure, yeah, f of 2. Forgot for a second there. So we want to evaluate f of 2, so we replace the x with 2 this time. Not so bad. So 2 times 2 squared, so the squared is just going to affect that second 2, plus 3. This becomes 2 times 4 plus 3. 2 times 4 is 8 plus 3, which is 11. So let's write our values here, since I sort of forgot to box. So to summarize, if f of x is 2x squared plus 3, then f of 0 is what? 3. F of negative 3 is 21. And f of 2 is 11. And there we go.